In this video, we're going to do some more derivative applications working with rates of change, motion, electrical, and tangents. Now the first one is just a rate of change. We've got temperature changing with respect to time. So we take the derivative of temperature versus time, which gives us 15.6 t squared. And we want to know the temperature changing with respect to time at 8.5 seconds. So we just evaluate it at t equals 8.5. Which gives us degrees Fahrenheit per second. Now this one we're given an equation and we want to find the tangent line to that curve at the point 2, 8. So we take our derivative, which is 8x minus 3x squared. Now if we put in the point, or more specifically the x value of the point, which is 4, this is our slope. So the derivative at a point gives us the slope of the tangent at that point. Now we know y equals mx plus b for equation of a line. The slope is m. We can plug in our point, and we end up with a b value of 0 or a y-intercept of 0. So the equation of the line is just y equals 4x. Now here's an electrical one. We have a 0.0025 farad capacitor. This here is our capacitance. We have the voltage, and we're looking for the current. So the equation we need is I equals C dV dt. So current equals the capacitance times the derivative voltage, which will be 64t plus 16. We can simplify this. Plug in our 2.5. Giving us 0.44 amps at 2.5 seconds. Here's another electrical. This time though, we have an inductor, and the 2.8 is our L. We want to know the voltage at 1.5 seconds, and we're given the current. Voltage is equal to the inductance times di dt. So 2.8 times derivative, which is 27 t squared. Simplify. Plug in the 1.75. Giving us 231.525 volts. Now let's do some motion. Here we have an object given with a displacement of s equals 50, t squared minus 0.75 t to the fourth. To find the velocity, we take the first derivative. And then at 1 second, which will give us 97 meters per second. Now to find the maximum velocity, we need to take the second derivative. Now, maximum height is when the velocity is 0. Maximum velocity is when the acceleration is 0. So we take the second derivative, which is 100 minus 27 t squared. We set this equal to 0 and solve for t, which will give us plus or minus 1.9245. But the negative really doesn't make any sense. We always usually think of time as a positive number, so we're only going to look at the positive value here, and we're going to evaluate the velocity at that positive value. Giving giving us 171.07 meters per second. This last example is parametric motion. So we have displacement both in the x direction and the y direction. So we're going to need our velocity in both directions. So the velocity of x is just the derivative of the x, which is 22. And then the velocity of x at 3 is just 22 because, in fact, the velocity is actually just a constant. No matter what time you have, you are at 22 meters per second. The velocity of y, however, does vary. The velocity of y will be 3.5 minus 9.8 t, plug in 3, and we get negative 25.9 meters per second. So these are the components of velocity. Now part B, I'm asking for the velocity. And remember, velocity is a vector, so vectors have speed and direction. So one of the easiest ways to look at one of these is just to draw out your vector diagram or velocity triangle. So we have 22 meters per second this way, negative 25.9 meters per second down, and we want to know the velocity overall and the angle. Now to find the overall velocity, we can just use Pythagorean theorem. Which gives us 33.98. And to get the angle, we can just use tan, and inverse of opposite over adjacent, which is negative 49.655. So the velocity is 34.0 meters per second at 49.7 degrees below the horizontal.